and I work for Blue Origin and Jeff Bezos. I feel like I have to confess that to start the thing. But I want to introduce my fellow panelists up here and kind of share their backgrounds. I have a ton of questions for them already, so we'll try to get through some of those, but make sure we allow time for all of you. So showing my age, I got to put on my glasses to read all these esteemed bios for everybody. But first off, to my right here is Dr. Erica Rodgers. She is the Director of Advanced Programs for NASA's Office of Technology Policy and Strategy. Erica defines and shapes studies of the agency and national importance to provide data and evidence-driven technology policy and strategy advice to NASA leadership. Erica leads the Science and Technology Partnership Forum and establishes coordination frameworks across U.S. government space agencies. Erica served as a research scientist for the Space Science Institute before joining NASA in 2014. As a research assistant at the Geophysical Institute and the Laboratory for Atmospheric and Space Physics, Erica developed scientific instrumentation for successful satellite and sounding rocket missions. While conducting research, Erica worked in the aerospace industry as a systems engineer at Spectrum Astro and as a manager of satellite operations at semi-remote NOAA tracking station in Alaska. Erica received her doctorate in space physics from the University of Alaska Fairbanks and her Bachelor of Science and Master of Science in Aerospace Engineering from the University of Colorado at Boulder. Go Buffs. That's where I went as well. So thank you, Erica, for joining us today. All right, on the very end there we have Brent Sherwood, former Blue Origin, so I think he's now reformed now. He's a retired space architect and consultant. He is the space domain lead for AIAA. From 2019 to 2023, Brent was senior vice president at Blue Origin. He grew a $1 billion business comprising the Lunar Human Landing System, Orbital Reef Commercial Space Station, Blue Alchemist Lunar Resource Technology, and several company-funded flight system programs. From 2005 to 2019, Brent was at JPL as a founding manager of the JPL Innovation Foundry and program manager for solar system mission formulation. From 1998 to 2005, Brent was at the Boeing Company leading human and robotic space exploration formulation, space station module manufacturing methods, and new business for Sea Launch, the International Space Station, and civil space. He holds a Bachelor of Arts from Yale, summa cum laude, Master of Architecture from Yale, and Master of Science in Aerospace Engineering from the University of Maryland. Thanks, Brent, for joining. And our last panelist is Dr. David Korsmeyer. He is the Deputy Center Director at NASA's Ames Research Center in California's Silicon Valley, where he has spent most of his career. Dave leads the center's overall efforts in research science and engineering developments that support NASA's missions in aeronautics, science, exploration, and technology. A real great opportunity to have him on the panel is because of all his work on NASA's next lunar rover, the Viper, or Volatiles Investigating Polar Exploration Rover. David has a BS in aerospace engineering from Penn State University, an MS and PhD in aerospace engineering from the University of Texas, and an MS in management from Stanford University. So thank you all for joining us today. Well, I'm going to just jump into it with a couple of slides if you're ready to switch those on. Oh, I got the clicker. Okay. I wanted to start a little bit with talking about something that the Artemis astronauts were down at a Washington Post live thing yesterday. And one of the things that came up already is the idea that when we go to the lunar South Pole, it's like the old real estate thing. It's location, location, location. And so a colleague of mine, while he was at Boeing, he's now at Blue Origin, Xavier Simon, led a paper that kind of looked at an extrapolation of what the South Pole would look like when all these missions start to fly there. So here's kind of a map of him projecting in 2035, and this is just his best informed idea of where all these missions can go. And you can see, and this does not include all of the international activity. This is primarily CLIPS missions and also the HLS missions. And you can see a lot of dots in a very small area. What's very interesting is to see this next chart that actually gives you topography. And you can see there are a lot of regions, and that's because the poles of the moon have a lot of, and especially the South Pole, have a lot of unique features that make different sites kind of the best places to go. So I just wanted to kind of set the stage as we get into dialogue that going to the South Pole and this next era of lunar exploration is going to be a little bit different, I think, than the Apollo era and what we did with the surveyors, because we're actually looking at some very crowded space where location matters a bit. So I'll end my dialogue there and start with some questions for my panel. I'll start with one for you, Erica. The prior lunar landing sites for Apollo and Surveyor have been designated lunar heritage sites by U.S. legislation, as we've heard today. How should future sites be identified, especially given the 2022 NASA OTPS report that was done by the office that you're in called Lunar Landing and Operations Policy Analysis that recommended restraint in determining future sites? So can you explain further what is envisioned?
Yeah, thanks for that. That was a good intro, Todd. Thank you for those slides. So I just want to take a quick step back to talk about in OTPS, Technology Policy and Strategy at NASA, we do a lot of studies to help inform our decision making, but it's always coming with a lens that's strategic and thinking holistically about what the community is doing, the whole community, the whole space community. And so that's the way that we view a lot of our motivation going into these reports, to then turn it into something like, what does that mean for the moon and all of the activity that will occur on the moon? So when we think about our engineering solutions then that we want to apply, we're also taking that same lens of what is the landscape of activity, and then how do we want to choose our engineering solutions. So as we're thinking of building up our capability over time on the moon, it's going to be a phased approach, right? This is 2035 that you showed on this map, and we're sending humans back to the moon, we're going to build up our capabilities, and then we're going to have this long-term sustainable presence as we envision over time. And this will be a buildup and capabilities over time, and it will change and evolve. And when we think about the activities that we have currently around the world, there's a global space economy that's over $500 billion. There are a lot of actors in space, many nations, and we want to understand that there's this global community. There's also this shift from commercial to private, as we've talked about here earlier today. And an example of that would be ISS, as we transition from government-owned platforms into commercial LEO destinations. As we do this transition, and we think about how capability has built up over time on the ISS, where we've gone from a little bit of utilization after we built it to a lot of utilization now, and the commercial activity that occurs at the International Space Station National Lab, 2/3 of that work is done by commercial entities. And so when we are thinking about our plans in future and going back to the moon, we're like drawing from lessons learned from what we've done on the ISS, and we translate that forward into our missions. We also think about our current CLIPS companies that our vendors are coming online and the capabilities that are being developed there. We have 14 vendors. They're developing capabilities to land on the surface, technology development that the entire community and NASA can leverage. And so there's this buildup of capability that we want to understand and take all the lessons learned and move that forward into building up our capability for the lunar surface. So that's the context that we think about all of these narrow passageways and sunlit regions where we want to do all of our exploration on the moon. Over half of the missions that are upcoming going to the South Pole region, and we could have a buildup of a lot of activity in small regions. So this report, thank you for calling that out, we released a report last year in our office in OTPS where we thought about these technical and policy considerations when all this activity will be occurring on the moon. And some of the things that we pointed out, similar to what you just showed here, Todd, high density, many operations within small areas, narrow passageways, and this could lead to situations of very close proximity of operations. And that starts to bring up a lot of the discussion we had earlier about policy. How do you have policy tools that are in place that help you communicate, identify these challenging situations that may occur? How do you be transparent, right? So we talk about in this report that we put out, it's very important to be transparent, to address all the community concerns that could come about. How do you coordinate with the space community, the international space community? And then how do you incorporate the policy tools that you define up front to be able to help you do that? So some of the examples that we point to in our report are landings. We've mentioned those earlier. Plume surface interactions can cause damage. So how do you account for those? How do you understand what's going on? Developing a standard for plume surface interactions. That was discussed just briefly on our science panel. Where are we on the state of that, and how do we share that information so that we have the understanding that we need for precise landing and to make sure that we are avoiding harmful interference? Surface operations as well can be damaging, so we need to understand what others are doing, what are we planning to do, how do we work around everybody that's going to be there. Safety zones were mentioned earlier as a potential opportunity. Those were written into the Artemis Accords as temporary location safety zones that we could have for particular operations. Navigating pathways, these small transit corridors, could be challenging if many people are going to be in the same location, traversing these same areas. What if there's a stationary asset and there are mobile assets? How do you understand where all of those players are going to be on the surface at any time? RF interference could be a challenge with some of the operations. There's the International Telecommunications Union, which exists already as a body that can be where you can work through and discuss RF interference, which is a possible mechanism that we could leverage for all other policy challenges that come up. Protecting human heritage. We also point out in our report, which is our topic here today, how do you preserve particular sites going forward? But all of these factors that we list in the report, it comes down to how do you balance what we want to do for our missions? How do we balance what's important? And how do we balance this international dialogue so that it's not just one person or one entity speaking forward? It's really a global community dialogue. So some of the work that we have going forward now is to think about continuing the global dialogue so that we can think about some policy tools that we could implement going over time. Thanks, Todd.
Thanks, Erica. So I'll throw it to Brett and David, and you guys can decide who goes next. You both have interesting perspectives on the new world we're going into of government-commercial partnerships. You know, David, of course, you've seen it being a payload for a future CLPS mission with Viper. Brett, you've seen it as being a commercial provider at Blue Origin. So what are your two perspectives? Because I think Erica did a really good job of laying out, you know, all the challenges we have of kind of this new order. There isn't just one group making these decisions. We're doing it through a variety of new partnership means. So you guys choose.
Okay, thank you. I'll try.
Yeah.
Thank Brent. Viper, which is the next big lunar mission for NASA, Volatile Investigating Polar Exploration Rover. Great name, makes you think of a snake, but its working title before it became a flight mission was called Resource Prospector. That's a little bit more appropriate characterization of what it's doing. It's a science mission, and you can see on the slide up there, it's basically a teleoperated rover. It's going to have a fair bit of autonomy. We've got 2 to 3 seconds time delay of control, and you can't really real-time joystick it. But you can do near real-time joysticking of it. So you can move it in chunks of 10 meters or so. It goes about twice as fast as the Mars rovers, about walking speed, 20 centimeters a second. It's about 1.5 meters to 1.8 meters tall. So that mast goes up to 1.8 meters tall. It's bigger than I am, and I'm a big guy. It's 1.5 meters square around the side, and it's going to land, as Todd mentioned, on a CLIPS rover. This is this commercial lunar payload services. This is a critical point to be made here. In the past, when NASA sends a mission, and this is a coming up on $400 million rover is what we're talking about here. It's an expensive mission. When we send a mission, we also send it the whole way. We buy the rocket, we develop the lander, we go the whole way. They changed the model. With CLIPS, they said, we're going to send a science mission. We're going to spend a lot of money on this thing, and then we're going to send that to bid. Who wants to take Viper to the moon? And please give us the cheapest ride you can get. And we're only going to tell you the general region of the moon, by the way, and only give you a few requirements. I need to be careful here, Todd, but from an engineering perspective, a requirement equals cost, right? If I require you to do something from an engineering perspective, it's going to cost you money. If I just let you do it, if I said, Brett, please go out and get me to the moon, but I don't care how you get me there, you could crash land me on the moon if I didn't make the requirement of land me softly so I can roll off and do something useful. So we got bids. We got a commercial vendor to come back who has never flown before, who has never built a lander, and who is very new to the environment. So we're bootstrapping the space economy. Yay, capitalism. But we got to get that lander there. And notice the blurry text on when we're going to land, because we originally signed a contract to land in 2023. We're in 2024. We're talking about 2025. I can't go there because that's contractual discussions. I can't tell you today because I can't tell you, and I can't tell you today because I don't know when we're going to land on the moon next. So getting into a new model of space economy gives some great freedoms to get some great benefits from industry, to allow them to be creative and do wonderful things, and hopefully bootstrap an economy. But it also means I don't know when my mission's going to go, and I don't exactly know where it's going to go. We told them a region we want it to be in. And I'm going to spend 1 minute just telling you the tricky part of this region is it's hilly. It's hilly because there's a bunch of giant craters. When you see pictures of the Apollo landing, you're thinking flat plains. That's not the South Pole of the moon. You're in a bunch of hills. There's permanently shadowed, some deep, some shallow, craters everywhere, and you don't want to go in there. It was said earlier, you're down to like 30 Kelvin. That's 30 degrees above absolute zero where all motion stops. You don't want to go in there unless you really know what you're doing. So you're going to be going on the permanently lit or mostly lit areas of the time, and those are those narrow corridors. So we're really hoping the landers come down in the right place at the right time, not in a shadowed crater. Over to you, Brent.
Yeah, I'll just say a couple of things in response to Todd's provocation about this new era of commercial. And the first thing I want to say is I strongly recommend that all of us discipline each other to be crisp with our definitions. I draw a very bright line distinction between something that's privatized and something that's commercial. And it goes like this. If I'm the government and, as Dave said, if I develop the whole thing, if a contractor builds something for me and we say DD-250s it to me at the end, that means I own it at the end of the contract. That's traditional contract development. If, on the other hand, the contractor designs it, builds it, and owns it, maybe even operates it, CLIPS missions, operated privately, the HLS missions not operated privately, operated by NASA, even though they're owned by the contractors. That's privatized. That's not commercial. That's privatized. Commercial means the dollars that are paying don't come from the public budget. They don't come out of the top line budget of the agency or some government entity. That's commercial. So this is very important in my mind because it loops back to the issue of all this activity that we're going to have in these crowded regions on the moon. And my message about that is it's going to happen way slower then people are afraid it's going to happen. And even the example of Viper that Dave just talked about is evidence of that. All the delays in HLS are evidence of that. So we have time before it becomes so crowded that everybody's trying to be on top of each other. And also, there's going to be less of it, and less of it is going to be successful. Because space is hard, the moon is really hard, and so my urging to the community is it's fantastic that we're talking about it, but let's not get all wrapped around the axle being fearful of people tripping over each other and people damaging each other's stuff, because it's going to take longer than everybody is telling you it's going to take, particularly if it depends on genuinely commercial development, because where are the customers? If it's genuinely commercial, there has to be a business case. You can't close a business case without a market. It requires customers. Who's going to pay? Somebody might pay to put a plant in a vial on the moon, you know, some private foundation thing. Somebody might pay to deposit ashes on the moon. It's hard to make even a CLIPS class mission out of cobbling together a bunch of genuinely commercial payloads, let alone a human scale mission. So all of these big missions are going to be partnered with NASA, which means in those contracts, NASA will have hooks and scars and conditions. And so I think, although it's great we're talking about it, it's not great to worry about it, because it's going to take longer and there will be strings attached.
Did we answer the question?
Sorry, I wanted to tell you how I really felt, but I thought I would just abbreviate.
All right. Well, I have a different view of bias for action on this one, but Brent and I, even as we work together, didn't always agree on everything. So that's fine. I do think.
Thank goodness.
I do think the good thing about what Brent is bringing up is the fact that we're just discussing these issues here. I think it was mentioned this morning. Apollo kind of happened, and then they discussed them after the fact. So I agree. I have some of the same cynicism scars that Brett has, that things don't happen as quick as we anticipate. But I think it's also an opportunity to be proactive versus reactive and wait till they happen. So I'll continue to encourage that dialogue. I'm going to jump around a little bit in my questions, but one of the things that Erica already brought up is, and the science panel kind of highlighted as well, is one of the things that's very interesting about the South Pole is it has a lot of areas with special characteristics. It has permanently shadowed areas, as we talked about, and I think there's probably a whole discussion we could have between scientists and others about how we should be approaching the water. You know, some folks would say we need to keep that pristine because it could be a record of primarily probably cometary traffic in the Earth-Moon system, and we need to study it appropriately from a science standpoint. You're going to have people that want to use it as a resource. Maybe that might be one of the markets for commercial in the future. We shall see. You also have right next door areas with special illumination characteristics. So, you know, one of the things that's fascinating about the South Pole is how the sun just kind of stays at the horizon, and that's what creates a lot of those regions. But there's also places of the right elevation that basically get to see the sun all the time. Those also could be valuable if we have enough need for it to help with, say, solar power infrastructure and different things like that. So one of the questions we have is maybe it'll happen slower, but as we look at these various locations, how are we going to address keeping them available? And if people land on them, that's where we get into the characteristics of, I think it was said in the policy panel, you know, weaponizing space heritage in the fact you could say, hey, I landed on this and I need to preserve this landing spot as being sacred. There could be commercial reasons you could you could do that as well and prevent others from using that location. So, Eric, I'll let you take first shot at that, and then let the others go. We'll save Brent for the contrary point of view. He told me he'd be contrarian, which I love, and David will too. So that's what it's all about. It's fantastic.
Well played. Some of the things that we're thinking about right now at NASA are how you, to your point, what are sites that are valuable? What does it mean to be valuable? And we started to do a little bit of research here, and there's really no formal process to identify or protect certain locations going forward. And so we started chatting with the folks inside of the agency and outside of the agency. We looked at the 2011 recommendations that we had talked about earlier. We also have in our Moon to Mars objectives a science enabling Moon to Mars objective that talks about the need for preservation and protection, areas of special interest, and that's really focused for us on high priority science, right, from a NASA point of view. And some of the things we started to figure out is that the nomenclature that people are using to describe, like, how would you protect a site, what does it mean, how do you assign value, are all different uses of the terms, right? Different communities, you describe this in different ways. And so we have some further discussions ongoing when people bring up a discussion about, well, what if we contaminate a site? What if you interfere with the work I want to do later? Or what if you are interfering with me now via your operations are conflicted with my operations? And that's part of the same taxonomy discussion that we're starting to really to fill out a little bit at the agency, that we think that this is kind of all getting conflated a little bit, right? So what we've done is we've put out to the community on our website, you can go check it out, it's nasa.gov/OTPS, a questionnaire to get some feedback from the community on how do you understand and what do you determine to be contamination? What does that mean to you? What does interference mean to you? And what does it mean to deconflict? And so this is our first step at just taking a step back and just trying to get the community on the same page and using similar terms that could be of use, right? It starts with us, then it moves broadly, it moves into international dialogue, and then it's a way that we can move forward. So please go and check that out. Some of the things that we have about these questions are related to the value of a site, asking about what attributes or characteristics are relevant to what you might want to do or your community. We're asking for some scenarios, perhaps, if you've got those envisioned or if you're already planning for that. And then what impacts the value to that site? What does that mean to you? Is it that something is impacting your vision of what you want to do there right now? Is it time dependent or is it not time dependent? Right? That's something that we're also trying to figure out amongst the community. Is there an aspect that's temporal with understanding how you might assign value to a particular location? And does that value change in a temporal way? And then something that was brought up, I think, in the science panel, Brett just mentioned it, about mitigations, right? How can you then mitigate, and what might that look like for the community if you want to do science in your site or other operations, and there can be some type of conflicting activity or conflicting science. So please go check out our website. We'd really like to hear from you. And what we're going to do with this information is take it, we're going to put it together, we're going to assess it, and then we're going to bring it back out to the community to have the next round of dialogue. But we think framework could be of use at this early stage, right? Before we get rocking and rolling on the lunar surface, how do you have a framework that allows you to characterize?
I got one, yeah. Because this is, why are we all going to the South Pole? Did anybody ask that question? Why are we all going to the South Pole? What was wrong with the front side of the moon? It was great. You could see it. It was smooth. You could drive your dune buggy around. What's so special about the South Pole? Location, location, location. That's the mantra of real estate. It's driven by a valuation. What is the valuation on the South Pole of the moon? It is the implication, and I say it very carefully that way, implication that there is accessible water ice on the South Pole of the moon. We do not know this. I am not a scientist, but I will stand up and I will tell you what my project scientist for Viper and L-Cross and many other missions have told me, we do not know that there is accessible water ice on the south pole of the moon. It's unknown. That's why this mission is going. It is to characterize the horizontal and vertical, there's a big 1 meter long drill in that thing, vertical and horizontal access ability of the water ices on the south pole of the moon. What we have some phenomenal remote sensing data that tells us there's a lot of neutrons in the dark shadowed craters of the moon. Well, okay, that's great. So there's a lot of neutrons. What does that tell us? Well, usually that means there's hydrogen, but it can be characterized in other ways too. There can be other ices down there. So we've only touched it once. That was with another mission that came out at NASA Ames called L-Cross, where we actually threw an upper stage booster at one of the South Pole craters called KBSA, threw a booster into it and had a chaser spacecraft that flew into the plume that blew up. And we were able to do spectral analysis and see, yeah, there's definitely water ices there. But we don't know much more beyond that because we basically atomized it by hitting it at a couple kilometers a second. So when it comes to why do people want to be there, it gets back to why do they think there's going to be a space economy? There's going to be a space economy if they can find a valuable resource, aka water ice, and they can sell it to somebody else than maybe just the federal government, like to each other, and allow other commercial activities to occur to mine other products that may exist there. But until we know whether it's a bunch of little BB-sized grains, whether it's fluffy dust only on the south pole of the moon, or it's actually ice cubes that you can actually stick a drill in and extract easily, we don't know what type of valuation we should put on it. This is, forgive me, I am a fan, but this is all Star Trek. Until we get the data, we don't know. And we need to get the data or we don't know. So the land rush, I hate to say this, could become a complete bust. We could all get there and go, sorry, we can't really make use of any of this hydrogen that we found in the craters. It really doesn't help us. It's completely inaccessible or unusable in any form. Let's go back to the front side of the moon where it's easy. How's that for a killer?
So, well, I'm going to take it one step further.
Oh, here we go.
No.
You can count on the engineers being so optimistic, can't you?
This is fantastic. I agree 100% with what Dave just said. So many uncertainties. Let's be hope-oriented. Let's say that the desire for there to actually be usable amounts of volatiles, including water, especially water, that turns out to be proved by Viper and maybe other missions with, greater traverse capability and going deep into PSR, all that kind of stuff. Okay, now we get to, I'll call it the real event, which is engineering the operational capability on the surface to actually make use of that stuff. When L-Cross determined volatiles from a PSR, mixed in with all these amazing volatiles were mercury and cadmium and other kinds of stuff you do not want in your water or your rocket propellant. And so doing discovery is the first step, then extraction, then there's all the refinement and usage before we even get to I would argue, the hardest question of who are those other non-government customers. I worry that people get all excited about space resources and it's actually a self-licking ice cream cone. Because at the end of the day, if the user of all those propellants is NASA, guess what? It's still $26 billion a year is the NASA budget. It didn't make the NASA budget go up. It's not necessarily going to increase the number of NASA missions because most of the dollars are not in the propellants or even the launches these days. It's in the finicky, expensive stuff that's doing the mission. So we have to be very thoughtful about what we're actually enabling when we talk about bootstrapping a commercial ecosystem in these faraway places. So I just encourage everybody to keep thinking, who are the customers? How much engineering, infrastructure, and investment to get to the point of touching those commercial customers is required. And that gives you a sense of the challenges in front of us. And don't get me wrong, I'm an engineer and an architect. I love the challenges. But let's not overlook how challenging it will be.
So I'm going to come back to you, Brett, with, so of course this past Sunday, the Chinese landed their probe on the far side of the moon. Yesterday they unfurled their flag on the moon and then blasted off to return samples to Earth. Kind of some thoughts on that engineering achievement and kind of the significance of it, because I think one of the things that's fascinating is we could be all chasing that pot of gold at the end of the rainbow and find out it's not there, but there's more than just us. And so what are your thoughts as more and more international players get interested? And I agree with both of you that it could turn out not to be something valuable. But if it does turn out to be something valuable, talk about what you think is the proper reaction in that case.
So my answer to this is very quick and positive, which is the more the merrier. There's a lot to learn, as Dave pointed out, and so ultimately humanity learns when people go and do these things. I think it's a tremendous engineering achievement, even though the Russians did sample return from the moon many, many years ago, robotic sample return. Right? That's okay. It's another player demonstrating it, getting it on the first try. An amazing thing. There are a lot of subtleties in the science value of samples, where you get them, how you select them, how much they've been altered by your presence there. Basically, sampling very close to a descent plume means you're sampling stuff you brought with you as well as what's there. There's been multiple proposals to NASA, to SMD over the years for a decadal priority South Pole Aitken Basin sample return. And it's just like sample return from Mars. The scientific selection of the samples to bring back is where all the magic is. So grabbing something, coming back, yay. That's a great thing, but there's a lot more to do to learn, and humanity will learn it with multiple actors, I think.
Okay, David and Erica?
Real quick, kudos and congrats to China and the engineers and technologists who pulled that off and the scientists who are making it happen. Phenomenally valuable, truly impressive, and they should be super proud. We will learn tremendous stuff from that, absolutely. It does bring us into geopolitics, which I'm not an expert in, and will only say we do things because other people do things, and other people do things because we do things. That's geopolitics. It's posturing. It's moving stuff around. It's thing engineers aren't really skilled enough to talk about. But history has shown that's the way the world works. So, yeah, the space economy happens too, but we have all sorts of funny things on little teeny islands in the Pacific for no real economic reason, but for geopolitical reasons. I expect that will happen in space too.
Nothing to add.
Nothing to add. All right. Well, we've had a lot of great dialogue up here on stage. I want to bring the rest of the room into this conversation with us. And so raise your hands with questions. We've got one in the back. A mic's headed your way. So.
Hi, thank you. I just want to go back to what Brett was saying about a business case and, the first step of mining is discovery. However, in the missions that are planned, I'm not seeing a solid plan for actually getting prospecting going. So, for example, in mining, the first thing that you would do is get some samples, but we need enough samples so we can use, for example, geostatistics to estimate the resources. I don't believe that we're going to get enough samples to get to what we actually want, which is like, what do we actually have? How do we estimate the resources? So wanted to hear your thoughts on this.
Yeah, very, very simply, Viper is a huge first step. It's a first step.
Yeah, let me just give a couple data points on that. So Viper is going to be up there for on the order of 100 Earth days, about 3 lunar days. So it's going to go light, dark, like, right? It's going to cover about 36 miles. As an example, Apollo 17, which was the longest traverse U.S. mission, was about 4.5 miles. So it's going to cover a lot more, and it's not just going to be in a loop. It's going to go all over the place and go in and out of PSRs, permanently shadowed regions. The idea about Viper doing that, and some of it's going to be lawnmower activities. We're literally going to go back and forth like you're mowing the lawn, basically over football field wide areas, measuring, sampling, drilling at different depths to get statistically valid samples, right? First order, not as much as we really want, but as much as we can get, of different regions. So we have different types of regions, the permanently shadowed, partially shadowed, fully lit, and we're going to measure all of those. And then the idea is to bring all that data back, now knowing where the volatiles are, at what depths they occur, where they're most common, and correlate that with LRO and Chandrayaan and ShadowCam data and get an idea, okay, if I see this from remote sensing, and this is my ground truth, this is what I get, and I'll do it over as the biggest region I can, and then we'll take that and we'll crudely map that onto the rest of the moon. Plop. And that'll be our first actually ground truth resource map. And that is so at the very edge of just beyond discovery into a little bit of resource characterization, but that's our best start.
Yeah, and I'll just add, that's the difference between exploration and science. So what Dave just laid out is the science investigation that uses the exploratory mission of Viper as ground truth, but it isn't just limited to what Viper itself measures. Hopefully that his description was clear for everybody. It's a real science mission. It's not just driving around looking for stuff.
Thank you.
All right. We have another question, right? I don't know where the mic is. There we go.
Thank you. Thank you, panelists. That is a question kind of following lines with actually looking a bit further ahead. So I know there's a lot of talks about having people eventually live on Mars or live on the moon and have a permanent presence. So I was kind of curious from this discussion here, what kind of engineering challenges or even political or geopolitical challenges present when trying to create that presence, permanent presence on the moon.
I'll start and then I'll let everybody join. One of the questions I ran out of time to ask is, and I think we have an opportunity now, is when we're talking about a sustainability strategy that has been brought up, we should already be thinking, I think, with some of the hardware that we spend a lot of money to get to the surface of the moon. How can we make that be hardware that could be recycled, reused, repaired, kind of starting to have that long view? Because the gear ratio of how much energy and ultimately dollars it takes to get something up there, you'd almost like each step to be something you could build upon. And so I think one of the keys is, if you take that long view, is a true sustainable strategy would be every single mission kind of builds upon the other versus being kind of independent activities and not necessarily having much of a thought as to how it could be used in the future. So I think that's one of the things we can do, but it's really hard to have that long view because usually you just focus on getting the mission that you're trying to do done. Other thoughts from the panel?
As a space architect, your question goes right to where I've spent 40 years living. I want this to try to be inspirational. It may not come out that way. The number of things we have to learn is daunting, but therefore exciting. And there are some really huge ones. So for example, in terms of living permanently, we do not know, no one knows, if 1/6 gravity is enough. We don't. We have data points at 0 and data points at 1. We have no data points in between. So there's a thing we need to learn. There's all the kind of practical things about resource development and construction and mobility and safety and all those things, some of which we talked about before. All of that is learning that's in front of us. So I think in our community, one of the things that we lose sight of when, we see view graphs, we used to call it view graphs, but sort of chart-based descriptions of mission architectures. We lose sight of all the things that have to go right between the start and the finish is really the next step. It's just another start, right? But every one of those questions is an investigation, it's learning, it's teams sharing data, figuring out what to do next. That whole phase is what I call practicum. So first is exploration. Artemis has to work, right? We got to get to a few places, and we got to establish a little infrastructure. Then there's so much to learn. Granular flow in 1.6G. We can model it, but until we get practical data, we don't know. There's so many things we just don't know, and that's exciting. Anybody who's a young professional or a student should think, my God, there's a dissertation there, right? This is how education is built. All those questions end up having to be answered, and so much of it we cannot know until we're there. That's the beauty of it, is learning it forces us to do the learning in situ. PSI came up multiple times today, plume surface interaction, and there was a question about what's the current status. So Phil Metzger, whom Michelle mentioned on the panel as kind of the expert that NASA goes, he just published last week 2 new papers, and it turns out that with these new models calibrated by Apollo camera data, he thinks now that our original estimates of the tons of material excavated by the LEM descent engine were off by a factor of between 4 and 10.
Low or high?
Low. So now you've got, the Mark 1, Blue Moon Mark 1's got 1 BE7 on it. The human one has 3 BE7s on it. It's going to land, it's a lot bigger than the LEM, okay? You've got Lunar Starship. It's got canted engines and all, but it's a huge vehicle. So, yeah, we'll model it. Great theory, smart people. It'll be really interesting to see it. And we're going to learn so much with every step we take that it's going to send everybody back to the blackboard. Well, whiteboard now, but you know what I mean.
I'd like to add on to that. So that was an excellent description. Those are like all of the what's. What do we have to figure out? What do we have to learn? What's the technical follow through as we go forward and evolve? The conversation right now is about how, right? Like, how do we do those things in the way that we want to? And that's all tied to responsible use, right? So if you want to think about a long-term sustainability, there are discussions about that now. We just put out at NASA our representation of back to Earth sustainability. Well, that's volume 1. We'll do other volumes that are thinking about cislunar space as well. But it's a conversation right now about how do we, as an international community, do these things in the way that we want to do them and in the right way.
Well, let me just chime in one thing. So NASA has got multiple personality disorder. We are of many minds about everything, and it goes for sustainability as well. So if you're on the science side, sustainability be damned. You want to get the science. Science uber alles. You pay and you get the science. That's it. You don't care if you reuse it ever again, because that wasn't what you were paid to do. You maximize what you were paid to do. On exploration, we want to explore, and if it helps us to explore, we will use sustainability. But if disposable works, disposable it will be. Trust me, go look at some of the photos of the crap we've left on Mars, right? Our parachutes are all over the place. So we need to figure out, and we need to be told what you want us to do, you, the public, who pay for the government to do this exploration and this science and these technology developments. Otherwise, we'll just do it to maximize whatever particular value we think is important. And if you haven't told us it's sustainability, trust me, we won't do it.
All right, so we've pretty much wrapped up this panel. I hope we helped everybody wake up after lunch with some spicy dialogue One more question? All righty, well, okay, we'll go ahead. We'll go ahead.
Okay, I'll try to be
Go
quick.
ahead.
So, thinking back, we talked this morning about Apollo and trying to think about conservation of that in hindsight. And I guess the shortest version of my question that I can give here is, should we be considering conservation or preservation or heritage as we're building future systems, particularly with the potential that they're going to be located close to each other in the future? So like, along with engineering and science considerations for landing sites, should there be some sort of consideration for heritage, and how might we go about doing that?
So I'll give you the short answer is yes. And I think that's kind of a good kind of end to this. I think today we just started the conversation. I think going forward, and we'll figure out what the right forums are, I think we have challenges we've already exposed, even with the existing sites. You know, should we preserve all the Apollo sites? Should we preserve, the first and the last, but we go to those other ones to explore for science? I think there's a lot more questions that we've asked today than we've answered. And so I think definitely, and that's a great intro to our next panel, which is all about the next generation. I think to pile on what Brett said, this is such an exciting time. I mean, I think literally today, if you were coming here and you were looking for a PhD dissertation topic, we've given away about 30 or 40 topics easily.
All for free.
All for free. I think we're in just a fantastic time where we're have all kinds of new questions. I think we're going to do it this time. A couple of us have been through a couple rounds of we were going to go back to the moon. I think we're already proving that we're going back to the moon with different things. Whether we'll have it as abundant as my earlier crowded picture is probably to be determined. But I think what's exciting is at least we're going back. And so I think yes, and please help us answer those questions in the future. So I'll stop right there, and thank you.
We have one last question in the
Okay,
back.
well, I'm trying to respect time.
Oh, yeah. You have 1 minute.
All right.
Okay.
And then it's snack.
Okay, yes. Go
Okay,
ahead.
so since we're at a museum, I want to
Yes,
ask
sir.
a very museum-focused question because we're getting a lot of pressure to talk about the future, and this panel dove into a problem that we have is how do we talk about all of these plans in a way that is as accurate and authentic as possible while still inspiring the public?
Yeah, for many years throughout my career, I found it fascinating that the public loves science fiction so much. And I want to believe that reality is just as exciting as what they see in movies, science fiction movies. It's just different. Like, there are no transporters or tractor beams, or there's no lightsabers, depending on which religion you follow. But there are these fascinating science questions. We get surprised at every turn, every mission we do. Every single science mission turns up surprises. In my opinion, and I think formal education and informal education, like say through museums, have a role in this, is bringing people along on that journey of discovery and surprise and understanding. It's not just about footprints, it's about learning how the universe works. And that gives us meaning and purpose, and to me, I guess because I'm a nerd, that's exciting, but I think our task is to excite people about that and the adventure of discovery and exploration in science. That's the best I can offer.
Yeah, the one thing I will say, just 5 seconds, is the universe and creation is so big and so complex and so confusing. It will take all of our lives and our species' life to figure it out, and we will still not touch it, right? That is aspirational. There is always more up to go after.
I think the other thing to draw a connection between both the science fiction and the science reality things is the best stories are not just about the successes, but the setbacks as well. And I think we all have to embrace, being comfortable with sharing how things are going to change, how things are maybe not happening as quick and all that stuff. Because I think sometimes we're tempted to always give the optimistic view, the crowded lunar South Pole view that I gave in the beginning. And the reality is the story is all about how we overcome setbacks, how we do those things. And I think that's an area we could get better at, telling the public the story. We sometimes don't give them enough credit that they can handle hearing about the setbacks, but I think they'll become more invested if they understand the struggle as well as the success. All right.
Yeah. Erica, do you want to have the last word on this one? Since everybody else has waited, or no?
No.
She waved me off one
She's the
time when
only
I
one
asked her if she wanted to
say anything.
Erica, any final words?
Oh, come on, Eric.
You get to close.
I will close with, I enjoy science fiction to an extent. My point of view is that if I can see a human element, that is much more inspirational for me. So I always offer that when you're thinking about inspiration and how do we be authentic in describing the work that we're doing, and even if it's forward thinking, that we are humans imagining a future and humans will be in that future. So that is what I offer to this discussion.
Good, Andy.
Thank you all.
All right, thank you, everybody.
Okay. We are now breaking for a short snack, and then we will come back for panel 5 on the next generation. Hope you'll join us.